Jumping back to page 215, number 8, still page 215, number 8, okay? This time it says, use the concavity test to determine the intervals in which the graph is concave up, concave down, okay? They didn't need to say concavity test. We don't need to capitalize that. That's nothing special. Just where is it concave up, where is it concave down? We know that by looking at the second derivative and looking at where the second derivative is positive and negative respectively. So here's our function. Let's find the second derivative. So y prime is negative 4x cubed plus 12x squared minus 4, and then y double prime is equal to negative 12x squared plus 24x. All right? So I need to know where this is positive or negative. So I really need to solve. So let's put it this way. Y is increasing when y double prime. So wait, not y is increasing. We want to know when y is concave up. Y is concave up when y double prime is greater than 0. Here's y double prime, so I need to know where negative 12x squared plus 24x is greater than 0. So you're solving a quadratic inequality. Do not try to solve this by, putting the 24x over and dividing by x, because you don't know whether x is positive or negative. That will flip the sign. You can't solve it that way. You need to solve this by factoring and graphing. Okay, so really we can look at it this way. We can say, all right, what does the graph of y double prime look like? And that's easy to do. What is a graph y double prime? Because it's just this negative 12x squared plus 24x. All right, so, and I can factor that to have negative 12x times x minus 2, right? So this is a quadratic function. It's concave down because the leading coefficient is negative. All right, so quadratics we know everything about. So it has a x-intercepts at x equals 0 and x equals 2. Right? So, and it's leading coefficient negative, so this is a parabola facing down. All right, so what that tells us is that where this is a graph of y double prime, right? And y double prime is positive on the interval 0 to 2. All right, so y double prime is positive on the interval 0 to 2. All right, and then we can solve also using the same graph if y is concave down. That's why I like solving by graphing, because you get everything, you get all the intervals right away. Concave down when y double prime is negative, and we can see from the graph that happens down here and down here. So that's going to be on x is an element of negative infinity to 0, union 2 to infinity. All right, so I can get all that by looking at the graph of y double prime. Some people, by the way, instead of making a graph, they like to make instead of making a 2D graph, they like to make a line graph like this. They'll put 0 and they'll put 2, and then they'll just do like test values from each interval. So they'll do like x equals 1 for test interval here, so I plug in here and I get positive 1, so I know I'm all positive in this interval. And then we'll plug in like 3 here, and so I plug in 3 and I get negative 12 times 9 plus 24 times 3. I work that out and it's a negative number, so these are all negative over here. And I put in negative 1 here, and I get negative 12 minus 24. So that's negative again, so these are all negative over here. So this is using a sign chart. You get the same intervals, but look how much work it is. I had to plug in 3 different values, whereas you still, to do the sign chart, you still have to factor it and get the x-intercepts. All right, so if I'm going to factor it and get the x-intercepts, why don't I just draw a graph, and then I don't need to do the sign chart. It's easier. All right, anyway, that's how you do that. Your homework on this section 4.3, homework is Chapter 4, number 1 through 17 odd, and a union 33 through 37 odd. That's the homework on this. Enjoy.